Hello, good morning everyone. Just a minute. Okay, myself Priya RK, and I have been teaching on Unacademy platform from the last 4 months. And in the offline mode, I have been teaching for JEE, NEET, and CET category from last 4 years. And there are a good number of ranks produced under my category. And this is about the plus subscription that you can view on your screen. So there are different plans to subscribe on Unacademy. There is a 12-month plan which costs you around 12,375. 6 months plan is there for 10,125, and there is also 1 month trial price, and this is only for the new subscribers, and it is around 2,250 rupees. So if you want to get 10% off on any of these subscription plans, you can use this code PRKLIVE. Use the code PRKLIVE in order to get 10% off on any of these subscription plans. Okay, now what is there in this subscription plan? Here you will be getting a premium content at very affordable price, and there will be live courses that will be conducted for you people. Definite doubt clearing sessions will be there. Quiz will be organized at regular intervals. There will be a separate batch for complete preparation for you people for various examinations. Daily practice papers will be provided. Mock test will be conducted, and also under a single subscription you can have unlimited access to the content on Unacademy platform. Very good morning Shweta, good morning Prathamesh, welcome Preetam, good morning, welcome Chaitra, good morning Gaudappa. Yeah, so let us begin with this session. So as you know, we are continuing with the electrochemistry chapter. Yeah, so in the last class we have studied about a Nernst equation, right? Nernst equation is E is equals to E naught minus RT upon NF ln of M upon concentration of M upon concentration of Mn plus. Good morning Pranjal, good morning Pradeep. Yeah, so if you want to remove this ln, what you multiply this equation is by 2.303. Okay, so equation would be E is equals to E naught minus 2.303 RT upon NF log of anode upon log of cathode, or product upon concentration of the reactant. So one question we had seen in the last class. Let us see one more question based on Nernst equation. Yeah, so here is the question. Calculate the EMF of the cell in which the following reaction takes place. So what we have to calculate? We have to calculate the E cell, that is the EMF of the cell, and the reaction has been given, and also they have given you E naught cell value. They have also given you E naught cell value. So here you can see E naught cell value is 1.05. 1.05. So what is given in the question? Let me just write it first here. E cell we need to find. E naught cell value is 1.05 volt. And if you see in this reaction, how many electron changes are happening? Nickel is getting converted into nickel 2 plus. That means 2 electron changes are happening. Therefore, your N value would be equal to 2. Right? N value would be equal to 2 because 2 electron changes are happening. Next step, what you need to see is write down the reaction which is given in the question. And you know the formula is E cell is equals to E naught cell minus 0.0591 upon N log of product upon reactant. Now how this value comes? 0.0591. Let me go back to the previous slide. If you multiply 2.303, gas constant value, as I said in the last class, it is 8.314. Absolute temperature, that is 293 Kelvin, and Faraday's constant 96487. If you just multiply these three values and divide it by Faraday's constant, what you are going to get is 0.0591. You can directly substitute this value You don't have to write all the values and then divide it. Directly remember this value. You can use this value directly and solve the question. Divided by n, that is the number of electron changes. Log of concentration of product. Now this actual equation is not there in your textbook, but for your ease I have made this because such reactions will be given, and even if you do not know which is getting oxidized, which is getting reduced, you can make use of this particular formula, product concentration upon reactant concentration. Now E naught cell value I will substitute, that is 1.05 volt, that is given in the question, minus 0.0591 upon 2, because 2 electron changes are happening in the equation. Nickel is getting converted into nickel 2 plus. Log of concentration of product. Now this is the product side. What is the concentration? 0.160. That I can write it as 16 into 10 raised to minus 2. 16 into 10 raised to minus 2 can be written. Concentration of reactant, that is 0.002. Right? So I can write it as 2.0 into 10 raised to minus 3. Now here I have taken square. Why? Because there are 2 moles of Ag plus. 2 moles. Here it is 2 moles. Whereas nickel was 1 mole. Here also you can see nickel is 1 mole. Therefore it is raised to 1. That we do not have to write it. Okay. So why raised to 2? Please keep in mind, always when there are stoichiometric coefficient, you have to raise to that power. Okay. Here you can see it is raised to 2 Ag. So it will be 2.0 into 10 raised to minus 3 raised to 2. Now just multiply this powers whenever it is power. 3 2s are 6, so it will be minus 6 here. Then 2 square is a 4, right? 4 1s are 4 4s are, right? You can write this as, I can divide this, 4 1s are 4 4s are 16, right? So 4s are, okay. Then 1.05 volt minus 0, if you divide this, then you get 0.095. Log of, now this 10 raised to minus 6, if it comes to the numerator, it will be 10 raised to plus 6, right? And you have log 4 here. I am just writing it as log 4. So if you solve this power, how much you are going to get? 10 raised to 4, right? Log 4 into 10 raised to 4. Log 4 into 10 raised to 4 is nothing but log A into B. Log A into B is nothing but log A plus log B. So log 4 approximate value is 0.60, right? Log 4 approximate value is 0.60 plus 10 raised to 4. Log of 10 raised to 4 is a 4 log 10, right? This if you solve, you are getting 10 raised to 4. So log of 10 raised to 4 is a 4 log 10, right? Fine. So 4 I will write as it is into log 10. Log 10 is nothing but 1, right? So just add these values. This will be 4.60. 4 into 1 is 4 plus 0.60, 4.60, right? Fine. Then multiply these two values, 4.60 into 0.0295. You are going to get 0.1357. Subtract these two values. Your final answer is 0.9143 volt. 0.9143 volt. Good morning, Mahalakshmi. Good morning, Ritik. Good morning, Sachita, Shafakat. Welcome, Sunil. Thank you everyone for joining. I hope this question is clear to everyone. Yeah. So try to simplify the things. You see, if you would have taken it as 0.16 and here 0.002, then it is difficult for you to calculate the log values, right? So try to simplify things and make them easier for yourself. Okay. Yeah. Next is equilibrium constant. How to find equilibrium constant from Nernst equation. Okay. How to find equilibrium constant from Nernst equation. So you know in Daniel's cell, what is the equation? Zinc plus copper 2 plus gives you zinc 2 plus copper, right? Plus copper. Now at equilibrium, this E cell value is always equal to 0. At equilibrium, E cell value is equal to 0. You know E cell is equals to E naught cell minus 0.0591 upon N log of concentration of the product divided by concentration of the reactant, or anode upon cathode, or oxidation upon reduction, right? So if E cell is equals to 0, that means it will be 0 equal to E naught cell minus 0.0591 upon N log of concentration of Zn2 plus upon concentration of Cu2 plus. Now what I will do, I will shift this entire negative value on the other side. on the other side. So this will be E cell is equals to 0.0591 upon N log of Zn2 plus upon copper 2 plus concentration. That's what I have written here. Now, log of concentration of Zn2 plus upon copper 2 plus can be written as Kc, that is equilibrium constant. So in the equilibrium chapter you might have learnt we write K is equals to concentration of C raised to C into D raised to D upon A raised to A and into B raised to B. Right? So the same value we can write it as Kc. So this equation would turn as E naught cell is equals to 0.0591 upon N log of this term we can write it as Kc. So this is your final equation where you can find the equilibrium constant. So here you would definitely need the knowledge about anti-logs. So I think in the last class I have taken about anti-logs. So I hope you are following that and understanding this particular concept. Okay. So we'll see some questions on this particular topic. If anyone has a doubt so far, you can ask me. Very good morning, Bhagyashri. Yeah. Let me go for the questions on this. Good morning, Shrishel. One more formula we should see, that is electrochemical cell and Gibbs energy. Gibbs energy is represented as delta G. It is represented as delta G. The formula is delta G of any particular reaction. This R stands for any reaction. Okay, is equals to minus NF E cell. This is under normal condition. N value you know, number of electron changes. F value you know, Faraday's constant. And E cell, that is the potential of the particular cell. Then under standard condition we add this term naught. So delta G naught is equals to minus NF E naught cell. F value is 96487, and if you don't want to use this exact value, you can use 96500 as well, coulomb per mole. So this is also very important equation in order to calculate the Gibbs free energy of any particular reaction. And also you can relate the equilibrium constant with the Gibbs free energy. This equation you have studied in thermodynamics chapter. The last topic was this one, where we have solved also some questions last year. So delta G naught is equals to minus RT ln Kc. Okay, or if you want to remove this ln, what you can do is delta G naught is equals to 2.303. You have to multiply to this entire equation. So minus 2.303 RT log Kc. K value you know, it is nothing but equilibrium constant. Okay, so we are going to solve certain question based on these two equations. And also you should remember this Nernst equation in terms of pH of any particular reaction. So E cell is equals to E naught cell minus 0.0591 upon N. Here we used to have a log of concentration of the product upon concentration of reactant, but in terms of pH you can just multiply it into pH value. And what is pH? pH is nothing but negative logarithm of concentration of H plus ions. Negative logarithm of concentration of H plus ions. Okay, let us see one question. Okay, the cell in which the following reaction occurs. Okay, there is a reaction that is given by them. Okay, this is the equation you can see. And E naught cell is given and temperature is given 298 Kelvin. Calculate standard Gibbs energy. Standard Gibbs energy means you should not write it as delta G. Okay, you should write it as delta G naught. You should write it as delta G naught. That you have to calculate, and also calculate equilibrium constant. That means Kc value also you have to calculate. Okay, equilibrium constant. First, let us see how many electron changes are happening. You can see here Fe3 plus is getting converted into Fe2 plus. Means definitely from here to here 1 electron change is occurring. But there are 2 moles of this. Correct? 1 mole giving 1 electron change. 2 moles will give you 2 electron change. Right? So N value would be 2. E naught cell value given in the question 0.236. 0.236 volt. Temperature given in the question 298 Kelvin. It should be in Kelvin. Okay. Fine. What is the formula for calculating delta G naught? Is equals to minus NF E naught cell. Minus NF E naught cell. minus N value is equal to 2. Faraday constant you need to remember 96487 into E naught cell given in the question 0.236. Your answer would be, if you multiply this, you can check, minus 45,541.864 joules per mole. This Gibbs free energy is always given as joules per mole. But usually they will ask you to express this energy in terms of kilojoules. So if you want to convert this joules into kilojoules, you have to divide it by 1000. Whatever value you have to divide it by 1000. So if you divide this by 1000, your answer would be minus 45.541 kilojoule per mole. So this is simplest part of this particular question. That is calculation of Gibbs free energy. 3 values you need to substitute. That is the number of electron changes, Faraday constant and E naught cell. And multiply it and convert it into cool kilojoules by dividing by 1000. Right. So this is first part. But they have also told us to calculate the equilibrium constant. Right. So let us see equilibrium constant. Right. So what is the formula? There are two formulas. You can just go back and see here. There are two formulas. One is this formula. E naught cell is equals to 0.0591 upon n log Kc. You can use this formula also because E naught cell is given in the question. Right. Number of electron changes is also given. And log Kc, here we need to find this term. Right. You can use this equation also. Even you can use this equation. Here also Kc is related to delta G naught. Delta G naught we have just found out. So you can even use this particular equation. Okay. That's your choice. Both will give you the same answer. So here I am using this equation. Delta G naught is equals to minus 2.303 RT log Kc. Delta G naught we have found out just now. Then 2.303 is there into 8.314. Now this value, which value you have to use, whether I have to use here kilojoules value or joules value, that is very important. Here 8.314 joules per Kelvin per mole it is. Unit for this gas constant is 8.314 joules per mole per Kelvin. So this is should be in joules, not should be in kilojoules. This value which you use here, it should be in joules. This negative and negative gets cancelled. Right? Temperature given in the question is in Kelvin. It should be in Kelvin because gas constant it is in Kelvin. Right? 8.314 joules per mole per Kelvin. So even this temperature, if it is given in degree Celsius, you need to convert it into Kelvin. But here it is directly given in Kelvin. So we don't have to worry about it. Very good morning, Preeti. Then what you need to calculate is log Kc. You need to calculate log Kc. Fine. So 45,541.86, which can also be written in this term. Okay. Into 10 raised to 3 also I can write. Okay. If you don't want to write it in that manner, you can leave it like this only and divide it directly. Divided by 2.303, 8.314 and 298. I will bring all these terms to the numerator. If you divide this term, you are going to get 7.983. You are going to get 7.983. We want Kc value, not log Kc value. Right? We want what? We want Kc value, not the log Kc. So I will shift this log on the other side. 1 by log 7.983. 1 by log is nothing but anti-log. Anti-log of 7.983. So what is the formula for anti-log? Very simple. Before decimal, whatever is there, you take it into the power. So 7 is there before decimal. So 10 raised to 7 I am going to write. Then go to 0.98. Go to 0.98 and C3. 0.98 and C3. What you are going to get? 9616. You are going to get 9616. So once you get this value, put one decimal after the first digit. Your value would be 9616. What you have to do? Put one decimal after the first digit. So your answer for this question is 9.616 into 10 raised to 7. Very good morning, Guru. Thank you so much for joining. So this is how you should find the anti-log also and Kc value. Okay. Next question. The standard electrode potential for the Daniell cell is 1.1 volt. Standard electrode potential means definitely E naught cell value they have given. Calculate the standard Gibbs free energy for the reaction. The reaction has been given. You have to find delta G naught. So first thing that you should know, what you should have in the question is E naught cell value is given in the question. That is 1.1 volt. N value I have to need. Fine. N value is nothing but number of electron changes. Zinc is getting converted to Zn2 plus. So N value is at 2. 2 electron changes are happening. Substitute the value in the equation. Faraday's constant, as I said, you need to remember, it will not be given in the question. It is 96487. N value is 2. E naught cell value given in the question is 1.1 volt. So if you just solve this, you are going to get minus, don't forget this negative value, okay? Minus 2.12271 joule per mole. If you want to convert it into kilojoule, divide it by 1000. So if you divide it by 1000, you are going to get 212.271 kilojoule per mole. Very simple question. Thank you, Sudham. Thank you for joining. So that's how you do any question based on Gibbs free energy. Okay, one more question. Yeah. So calculate the equilibrium constant for the reaction. The reaction has been given and E naught cell value is 0.46 volt. Okay, E naught cell value is 0.46 volt. What we need to calculate? Kc value we have to calculate. First thing you should know is which formula I have to use. So here Gibbs free energy is not given. So we'll use this other formula. E naught cell is equals to 0.0591 upon n log Kc. Okay, we'll see how to use this formula also. Other formula we have used to calculate Kc. Let us use this formula as well, how to calculate Kc from this particular equation. So if you see here, number of electron changes, copper to copper 2 plus. That means 2 electrons it has released. Therefore, number of electron changes equals to 2. That is N equal to 2. E naught cell value is given in the question, 0.46 volt. Kc value you need to find. Equation always, first what is given in the question you have to write. Then you should write which equation you are going to use. E naught cell is equals to 0.0591 upon n log Kc. So E naught cell value I'll substitute 0.46, that is given in the question, and n value also I'll substitute, that is 2 log Kc. So just to divide this 2, how much you are going to get, or else you can shift this 2 on the other side and that is to the numerator and 0.0591 to the denominator. If you solve this 0.46 into 2 divided by 0.0591, you are going to get 15.60 volt. 15.60 volt. You can just cross check this one. Okay, even you can cross check whenever you feel like it's a problem. You can always cross check. Okay, whenever you have a question, I always prefer you that you cross check every answer. Good morning, Sanjana. Good morning, Priya. Yeah. So all of you can cross check, that is 0.46 into 2 divided by 0.0591. So definitely it is 15.566. You can sum up it into 15.60 volt. Okay. So this is a log Kc, but I want the value of Kc. So I'll shift this log on the other side. So if you shift it to the other side, it will be 1 by log, right? To the denominator it will come. So 1 by log of 15.60. 1 by log is nothing but anti-log. What is the simplest method? Take this, whatever is before decimal, whatever is there before decimal, take into the power. 15 is there before decimal, I'll write it as 10 raised to 15. Then what you have to do? Go to 0.60 and see 0 only. Next nothing is there means you should think that 0 is there. Okay. So go to 0.60 and view 0. What you are going to get? 3981. 3981 you will get. Go to 0.60 in anti-log and see 0. I've taught you this anti-log and log twice. So I hope you guys have seen that video. And if not, then please go to that video again. Last class also I have taken this log and anti-log for those who had missed it. So if you see 0.60 and again 0, you will get 3981. And after writing that, put one decimal after the first digit. That's how you find the anti-log. Okay, very simple. So yeah, thank you everyone for your patience listening. If you have any doubts regarding any of these questions, you can ask me. My next YouTube session will be on 18th of this particular month, that is day after tomorrow, on Friday. Yeah, I think on Friday. Yeah, today is Wednesday, Thursday, Friday. Yes, on Friday there'll be YouTube session. And the continuation part of this particular chapter would be taken, right? So let me just revise what I have taught you people. So this was the Nernst equation. Nernst equation have different forms. E is equals to E naught minus 2.303 RT upon NF log of concentration of the metal divided by concentration of the metal ion. Or else you can say it as E cell is equals to E naught cell minus 0.0591 upon N log of concentration of the product divided by concentration of the reactant. So whenever you have such equation, it will be very easy. So product concentration you can see and reactant concentration you can see and directly substitute. Or else concentration of the oxidized product and concentration of the reduced one. Okay. Or else concentration of anode upon cathode. All these forms will be very useful in one or the other form. So please keep in mind these formulas. And this was one question that we solved on Nernst equation. Next is very important formula, that is equilibrium constant from Nernst equation. So what is the equation? E cell is equals to, this equation is very important. E cell is equals to 0.0591 upon N log Kc, right? Okay. And then Gibbs free energy for any particular reaction can be calculated from the equation delta G is equals to minus NF E cell. This is under normal condition, but under standard condition, the equation would be delta G naught is equals to minus NF E naught cell. F value 96487, that is Faraday's constant, Coulomb per mole. Then you can even relate Gibbs free energy with equilibrium constant. So delta G naught is equals to minus RT ln Kc. So if you want to remove this ln and convert it into log, what we did? We multiplied the entire equation by 2.303 RT log Kc. So this is very important equation, and even this is very important equation, right? And in terms of pH also you need to remember E cell is equals to E naught cell minus 0.0591 upon N into pH, and pH is nothing but minus log concentration of H plus ions. So one more question we solved on Gibbs free energy and equilibrium constant. So standard Gibbs free energy means you need to use this particular formula. There is no difference. Calculation would give you the same value, but writing this equation is very important. So that's how if standard Gibbs free energy is asked, you use this formula. If Gibbs free energy they are asking, then you should write this formula. Only differences between the standard conditions that you mention. Okay. Okay. So here standard Gibbs free energy was asked. So delta G naught is equals to minus NF E naught cell. So minus 2 electron changes in this particular reaction into 96487 Faraday's constant, that you have to remember. E naught cell value is given in the question 0.236. So if you solve this, you are going to get 45,541.864 joules per mole. If you want to convert this joule into kilojoule, what you need to do is divide this entirely by 1000. So if you get 45.54 kilojoule per mole. Then units are very important. If you do not write the units, then it will be problem for you. Here we have calculated Kc value, that is delta G naught is equals to minus 2.303 RT log Kc. So here R value is in joules and also R value is in Kelvin. So temperature should be in Kelvin and this G value should also be in joules. So 45,541.86 only I will use, not this kilojoules. Minus of that is there, and minus 2.303 into 8.314 into 298 into log Kc. So please remember this signs and symbols also, because they are very important. If you just miss this negative sign, though your answer is correct, then it will be not acceptable. Okay. So bring all these terms on the other side, divide this 2. If you divide this 2, you are going to get 7.983. Log Kc equal to 7.983, but I want only Kc value. So I'll shift this log on the other side, it will be 1 by log. The numerator will go into the denominator, so it will be 1 by log. 1 by log is nothing but anti-log. So anti-log 7.983 is nothing but this power, whatever is there before decimal. Before decimal only 7 is there. So the 7 will go into the power, okay, and go to 0.98 and C3. Okay, go in anti-log table, not in log table, okay. In anti-log table 0.98 is there and view 3. If you see 0.98 and C3, you'll get 9616. You'll get 9616. After getting this value, put one decimal after the first digit. That is after 9. So it will be 9.616. Likewise, here there is also calculation of standard Gibbs free energy. They have given the standard electrode potential for Daniell cell, that is 1.1 volt. Sometimes they may not give you that it is 1.1 volt. They may even say the standard electrode potential for Daniell cell is taken. So you need to remember that it is 1.1 volt, because Daniell cell, as I have already mentioned, it is very important. Their potential is 1.1 volt and concentration of the reactants and the product is 1 molar. So they are asking you to calculate standard Gibbs free energy. E naught cell value they have given 1.1 volt. Daniell cell equation also they may not give. So you should be able to write this Daniell cell equation. Okay. So remember this equation, it's very important, and even this value of electrode potential for Daniell cell is 1.1 volt. So number of electron changes from zinc to Zn2 plus 2 electron changes are happening. So 2 I will write. Delta G naught is equals to minus NF E naught cell, that will be equal to minus 2 into 96487 into 1.1 volt. So again you have this joules value converted into kilojoules by dividing it by 1000. Likewise, we have used this particular equation, E naught cell is equals to 0.0591 upon N, to calculate this Kc value, right? So here also you have anti-log values. So please attend the next live session on YouTube, that is on 18th, and continuation part of this electrochemistry chapter would be there. And thank you everyone for joining the class, and if you like this video you can give a thumbs up, and yeah, have a good day.